This is the review and reflect for alternating series. For the review, you're going to be asked to determine the convergence of the series, and it's asking you to find good choices for the comparison test. So we're going to use the comparison test as well as the limit comparison test to determine the convergence of these series. The reflect is for you to ponder about what we covered today and what we have been covering and how they are related. You might want to pause the video here so that you can write down both the review and the reflect. Instead of doing all the problems in the review, I'm going to do a select few so that you can see the method in which we are going to use to determine a good comparison test as well as to actually find the convergence. Big things to remember is that when you're using the comparison test, you want to make sure that you compare it to something you know, such as something like the p-series or a geometric series, in particular a converging geometric series. From there, recall that the limited comparison test as well as the regular comparison test states that if you can decide what is happening, then you can conclude that both of the series are doing the same thing. So let's get started on number 2. Notice for number 2, we're going to see that our series looks a lot like 1 over k. And remember, we know that this is our harmonic series which diverges. So let's compare what we have. We have k squared minus 1 over k cubed plus 4, and we want to compare that to 1 over k. We cannot decide which series is larger than the other, but we can use the limit comparison test because we do know that 1 over k, that series actually diverges. So using that, I'm going to find the limit as k goes to infinity, and I'm going to get our original equation of k squared minus 1 over k cubed plus 4, and then we're going to divide that by the series that we're comparing, which is 1 over k. Don't forget that when we are dividing by fractions, it's the same thing as multiplying, so I'm just going to multiply this times k. And now that we're multiplying, we're going to find that we're finding the limit as k goes to infinity. I have k cubed minus 1 over k cubed plus 4, and we see that that limit is equal to 1. From the limit comparison test that says if you have a limit that is a definite number, a finite number, some number between 0 and infinity, which our case is, then this series does the same thing as the one we are comparing. Since the one we are comparing diverges, we can conclude that our series also diverges. And this is by the limited comparison test. Let's try number 6. For number 6, we have a series of 1 over 3 to the k minus 2 to the k. Well, it kind of seems logical that we can probably compare that to 1 over 3 to the k. We can see that this series is a converging geometric series, so this one converges. So if we want to do a limit as k goes to infinity, and again I'm going to do the division of these two, and I'm going to pick 3k minus 2k over 3 to the k. And the reason why I'm doing that is because that looks more familiar to one of those limits I've asked you to memorize. And we can see this to be the limit as k goes to infinity of 1 minus 2 to the k over 3 to the k. So I can do it something like this. Because we know of our geometric series, we know that this will converge to 0, and we're going to find that our limit here is equal to 1. Again, because our limit comparison test is a finite number, then both series will do the same thing. So we're going to find that our series for number 6, the 1 over 3 to the k minus 2 to the k, actually also converges. And that concludes this video.